I want to start then also with my own story, which I don't have on a slide. I found out that I don't even have the text anymore of my PhD thesis. So it's not only that it's stored in WordPerfect 4.2, no, it's actually LaTeX, so I was very advanced, but I lost the source file. So yeah, mine is also bad, but luckily this happened after my PhD was finished. So there are people that have the tendency of leaving their rucksack in the in a pub, and then actually this contain the drive that is in there contains 5 years of research data, apparently not backed up to anywhere else, like Mr. Panda Bear with his USB drive. It's the only copy of this data, and he devastated the whole research. So this is a serious case of a bad case study, but it's also actually quite close to our heart. Maybe we don't leave our own rucksack in the pub, or it gets stolen at the pub, but our PhD students leave our labs. And where does that leave this data? We won't be able to find it. So it's actually quite close by. And then, yeah, so we need data management planning. And what we see, I said already this morning, we have a tendency to say this is irritating. We don't want to make data management plans. And the funders actually say this is irritating. We don't want to judge data management plans either. So the tendency is actually that when I first got involved, the data management plan questionnaire by a funder was about 40 questions. I think we're down to 6 now. Soon we will have only 1 left. So this is the incredible shrinking data management plan. This is the first circle. And it sounds very bad. So we put data management plans in place with a reason, but there is a reason for the shrinking data management plan, and there is one comparable thing actually, and that's the ethics question. So in an application, you always have to tick a box saying, I am complying with all the ethics regulations. I consulted the ethics team to ask for whether my project was okay. And this is actually something that could happen for data management plans as well. If every institute has a department of data management planning, they could be certified to say, yes, this is okay. And then the tick box is okay. You don't actually need to have a complete judgment procedure in place at the funder. But still, I think, and that's why I have a second circle here, that there is also a good reason to actually extend data management plans, and then I call them data stewardship plans, to just make the distinction. It will help if we know what are all the things that can actually benefit our science if we do them better. So I'd like to see a growing data stewardship plan. Not as an obligation again, but as a benefit to our own research projects. So another example of what happens is, and I paraphrased it here, but this actually happens to me, and people ask me, can you please give me a good data management plan so that I can apply it to my research project? And that's not the way it works. These people are obviously trying not to become a bad case study, so that's a very good intention. But I actually don't have a data management plan that works for everyone, because every project is different. You can't copy somebody else's project plan either. So I don't have, and I can't have, a generic solution here. But what I do have, one of the people that I explained how this works actually went out and made a really nice data management paragraph. It's about 1 page, and so this is the first few lines, and it describes actually how they will make the data management plan in the first 6 months or 1 year of a Horizon 2020 project. Yeah, I hope the QR code works for you. That was the idea. So, and this is all based on FAIR. So they describe how to use FAIR to actually make the data management plan. And this is what I told about this morning. Data management planning with, in the back of your mind always, what do I need to do to make the data as fair as possible? So the actual data management plan, of course, then requires thought. You have to think about things. And I've judged data management plans for funders, and what you see is that 80 to 90% of all the questions I don't even look at when I judge the data management plan, because all of those are just things that you have to think about when you're making the research. So it's not something that the funder actually requires. Those are already things that benefit the science and are suggestions to think about from your funder. But there are really very many of those aspects, and it's incredible to see that you would think about all of them yourself. And I can explain that. So who of you has a photo library at home? Many, huh? Many people have a photo library at home. So many researchers actually think, I have a photo library at home and I'm maintaining that quite well. So maintaining a slightly more complicated data set in the lab shouldn't be a problem. We can do that ourselves. We don't need any services from the university or from the hospital for that. But there's, you're forgetting something there. Because there are three big differences between your photo library at home and the research data that is being worked on in the lab. One, it's bigger, significantly bigger. So let's say 3 orders of magnitude bigger. So anything that you do on your library at home, for instance, reorganizing it and it takes an hour, if you would do the same thing at work, it would take 1,000 hours. That's half a year for a person. That doesn't scale. So that's complication number one. The size is really much bigger. The second difference is that it's more varied. So in your photo library at home, there are one type of files, probably, JPEG. And if you're really an avid photographer, then there are also RAW files in there. So that's 2 different types of files, and the relationship between those 2 is quite obvious. This is not the case in the lab. We are having really many different types of data, and the interrelationships are really not always clear. And it's not that they are next to each other in the same directory or that they have the same name. No, they are treated in different ways. They have different pipelines of data working on them, so they won't be in the same folder, they won't have the same name, but they're still interrelated. It's not pairwise. So it's really different from a photo library. It's much more difficult, it is varied. And then there is a third problem with the data in the lab. And the third problem is that the data is operated on by multiple people. You are working on your research data with many people. Your photo library at home, you do yourself. But at the lab, there are probably 20 people that are working on the same data every day. And a coworker may have changed something because he saw a conclusion. If that is not planned, if that is not properly annotated somewhere, and you haven't planned for that, then you are not understanding your own data anymore. So, data in the lab is larger, it's more varied, and it's operated on by different people. So that makes data management in the lab really difficult and requires planning. And now, back to those people that have a photo library at home. Are you really managing it so well? Or do you have the same problem that I have with my 55,000 photos, that if I talk about a story, about a holiday to someone, and I'm looking for that photo, I can never find it. Yeah? So even at home, I suck at making data management. So, the thought really goes in, we really need experts, actually external experts to help. So what makes an expert? Well, an expert probably had his own problems in the past. So the difference between a novice and an expert is that an expert has failed more often than a novice has tried. So we've already told our horror stories that made us experts in data management, but there are lots of stories, and I can go into depth into any of them. One really nice example that I cite very frequently is a project called the Genome of the Netherlands, where 750 genomes of human beings were sequenced. And the computer system at the University of Groningen was nearly new. And they had basically infinite disk space available. They didn't have to clean up. So they had something like 200 terabytes of data and 600 terabytes of intermediate data that were created by all the intermediate steps, and then poof went the file system. No problem at all, because they had dealt with it in a very professional way. Of course, all this stuff was backed up. They just had to play it back from tape. But they had to play back from tape 800 terabytes of disk. And playing back from tape 800 terabytes took 4 weeks. And this was a time-critical project. If only they would have thrown away the 600 terabytes of intermediate data. It would have taken them 1 week to restore the data, saving 3 precious weeks in a time-critical project. This is not something that you think of if you make a data management plan. But now, if you show your data management plan to these experts in Groningen, they will say, I would never do it this way. You should delete your intermediate data as soon as you don't need them anymore. And this is expert advice that comes from people that got that expertise because they failed at this themselves. Another example is a project where I got the data management plan. And they just asked me for help. And they said, okay, we are dealing with a lot of data, and this is really taking a big chunk out of our data, of our budget. So instead of asking the computer department to make a backup of all that data, we have decided to make a backup on hard drives ourselves and put them in the safe. And this amounted to 200 terabytes of data. And they were convinced that this was fine until I calculated with them how long it would take them and how much time investment of their PhDs or postdocs it would take to actually get this done. And they reverted to using the system management of the university because that's much cheaper. I already told you this morning about another project where I got the data management plan, and I found out that they underestimated the costs for data storage by a factor of 100. So instead of it being a fraction of a percent, it was nearly 40% of their budget that they would need for storage. So they had to slash their work by a factor of 2 under the same budget conditions. Of course, we could solve that. But if you find out afterwards, you really have a problem. So these are really disastrous problems. And another very funny example was, I was a whole series of data management plans that I had to look at. And in one of them, they had not budgeted for the publication of the data. They had a 1 terabyte data set, and they just said, well, we'll dump that at the repositories of the data archiving and networking services in the Netherlands, DANS. So I know these people. I just called them up and I said, okay, did they ask you? No, no. Can you deal with a terabyte of life science data? No. Okay, thank you. So I got back, and they didn't get a very good review of their data management plan, of course, but on the other hand, they couldn't know. So yeah, you need to consult experts to get data management planning good. Well, a very shocking statistic that I got recently is that over 50% of researchers do not properly back up their data. Or, and the number becomes even larger if you ask, did you ever test the backup of your data? Did you ever restore something? And from my personal, this number shocked me. I know that a lot of people are not making backups, but that it's so pervasive even in research, that shocked me. But I know from my personal experience that the only people, private people, that are making backups of their computers are people that have suffered losses themselves. So apparently, we refuse to learn from other people's experience. And I hope all of you know that you have backups of data for 2 reasons. One is catastrophic failure of your equipment, and the other one is the slip of the finger. And they really require a different kind of backup. So they require different backup schemas and different backup procedures. So again, all of these are, please consult the experts that are there. And a lot of the universities and institutes, they have a lot of services that can help with these aspects and preventing these kind of problems. So a lot of the problems you really never hear about, of course. So if a project really fails because the data is lost, it's unlikely that you hear about it. They don't tend to be published in Nature. Yeah. So there is a broad expertise. The library and the IT department of your institute, they really help with their aspects of data management. And they are sanctioned to be a service department, to help others. But that's not the only thing. I already gave this morning, I think during the questions, an example where the expertise of research groups is actually necessary to do the research. And since research is so much broadening, we actually need to consult each other as researchers to actually get things done. And some of these expertise may not be in your own old-fashioned network, so you don't know these people. And look, it's irritant if you don't know where to find expertise. Huh? But it becomes painful if you don't know that it exists. And it becomes dangerous if you don't know that you need it. And I happen to see from experience that making a list of services is useless. Like a list of computer programs that can do tasks for data management is useless because the people that need them the most, they don't know what they're missing. They don't know that they need it. They're falling in the dangerous category. So again, you need to have a person, not a list, a person involved, an expert that can help you to see the data management. Actually, I'll show you. And there was already a slide by Erik on the data management wizard. I'll show you a little bit how that can help a little bit. But I'm still convinced that a person in an institute that helps out with data management is essential. But to show you how useless lists are, I am not selecting the apps that I have on my phone from a list. I have learned about those apps from other people. Because there is no point in going through 1.3 million apps, of which probably 600,000 are to-do item list managers, to select the one that actually works. So you need your network. You need people that actually have the experience and that advise you what to use. So, in the remainder of my talk, I will walk you first through a number of the common cases based on the 4 letters of FAIR that can help you in doing your own data management planning. And then I'll go back to this data management planning wizard. So, we start with the F from Findall. First thing is all the data needs to end up in a repository. Now, there are several different types of repositories. Yeah, I list 4 here. So they're domain-specific, institutional, national, and special repositories, as I call them. So domain-specific is, for instance, a repository for people that are studying language, where you can store all the audio samples. And what is special about that repository is that it doesn't have a button download, because if you have an audio sample, you don't want to download it, you actually want to listen to it. And similarly, if you have a genome repository, you don't actually want to download the genome if you find it. You actually want to have a genome browser as part of the repository. So it actually makes sense to have a domain-specific repository. Unfortunately, not for all kinds of data. There is a domain-specific repository, and also, unfortunately, you're not always allowed to use it. So some institutes or some countries say you have to use a national repository or an institutional repository. Those make your data less easy to find for others, because if all the audio samples from dying out languages would be in the same dying out language audio domain-specific repository, then everybody would be able to find it easily. But if part of it is in institutional repositories, that doesn't work. And the most specific actually is a special repository. And this is a really dangerous one. This is when you say, well, you know, I have my own website and I'll put it on my own website for eternity. Because the problem is, you won't be there for eternity, and that server won't be there for eternity. So who is going to make sure that it's going to be there for eternity? So that's about choosing a repository. You can imagine what my preference would be for the findability of your data. Now, many of the repositories that are there, they will allow you to get a persistent identifier for your data. If it's possible, do it. You get the credits. It's much easier to get the credits for a data set that is citable, and that really helps if you get a DOI for your data set, for instance. And then if you still doubt about the findability of your data, make sure that you list it in a catalog. Catalogs can point to the data set. They don't actually contain the data, but they contain some metadata that makes it findable by pointing at the repository where the actual data can be found. And here, it's clear that you have to contact the repository before you actually start depositing there. And it really helps if you contact the people that maintain the repository. They will tell you it helps us if you collect this and this and this metadata, because that's what we want. We want from you this kind of metadata if you deposit. They also probably want to plan how big your data set is for their work. But it's not the only person that you have to consult here. I already talked about the chest X-ray. The chest X-ray that was reusable to study the aorta, even though you used it yourself to study the spine. If you store such images labeled as how you use them instead of what they are, the reusability suffers just from those keywords. If you say these are X-ray images of the spine, then somebody studying the aorta won't know that he can reuse them. But if you store them as a phase contrast image of the chest, it is probably much easier to refind. So, that about findability. Let's go to accessibility then. Well, we already talked about the decay of links, but also repositories themselves have a decay. There are certifications for repositories. So a certified repository is a very good idea. And many data management questionnaires will actually ask you, is the repository where you want to deposit your data, is it certified? The certified repositories, the certifications are talked about between the repositories. There are several different certifications up to an ISO level, which of course takes years to acquire. But what is very important is that such a repository always has a backup that if they go belly up, the data will still be transferred to another repository that will stay alive. And this is definitely not the case for your own run repositories. And a very important other thing, and that's also by the Panda movie, but also in the questions of the morning, the software longevity is also very important. Software is also data, so make sure that the software, not only the source code, but also runnable, actually is still capable of reading the data. Repositories, they often charge a one-time fee. That's also an important thing to say. So if a repository charges a one-time fee during your project, you can actually pay it from your project money. If you run your own repository and you plan to keep it alive for 10 years, that means that 10 years starts when your project ends and you're no longer allowed to spend project money on it. You won't have any left. So you will need to plunder future projects to keep your old repository alive. This is dangerous. So it's a very good idea to actually assign this task to someone else. I think we've had so many questions about the legal conditions, about can this data be public, can this data be deposited, that we don't need to go into very much detail here. Privacy sensitive data, keep an eye on what you can do with it. But on the other hand, from the bingo card, we see that there are lots of reasons or pseudo reasons to delay publication of your data. And when I judge a data management plan, I really look for a limited embargo. So if people say the data will be published as soon as the patent has been accepted, then they get a low grade from me, because I don't know whether the patent will be accepted. Maybe the patent will be rejected and then the data will never become free. So no, that's not a good idea. And similarly for when the paper is out, A, which paper, and B, maybe the paper is going to be rejected or the results will be negative. But storing the base data of a negative study, those data may be very usable for another study. So they should be published, even if your results are negative. And then, yeah, so non-legal reasons to delay publication I find difficult to do. And the last thing is, yeah, the proper the IT procedures. Nobody wants to talk about the backups, but it is essential that you do it well. And it is not done well if it is a task of the postdoc on Friday afternoon, if he happens to have time after the drink. So after accessibility, we go to interoperability. And the interoperability, very important to use a format that is known to co-workers in the field. So if everybody uses the same formats, it really makes things better. And defining a new standard, just don't. There are so many standards already. In Elixir, there is a project called FAIR sharing, where you can find 1,000 databases and standards. If you look through that, you will probably find a standard for your data as well. Then the terminology is also a very important one. So if we use text forms in columns, in columnar databases, it's very difficult to join them up with others. This is the task of the verifier that Eric told about. But for us, in life sciences, it's quite obvious that we want to use an ontology instead of a text field to identify cancer and somebody else malignant neoplasm. But it's less obvious that we do the same thing for the place where the sample was collected. But if you really want to be interoperable, this is a necessity. Because interoperability doesn't end at the wall of the silo. Because true interoperability doesn't have a silo. It's interoperability not only in your own field, but also with others. And I have beautiful examples of where this really helped. Some people in the Netherlands had collected 1,000 Arabidopsis plants from all over the world and sequenced each of them. And then somebody suddenly said, hey, it's interesting to know whether there is a correlation between these mutations and the height at which the plant was growing. Does it have to do something with the density of the air or the temperature, but that correlated with the height? And because they stored the location in the way geologists store location, they could easily link out to Google Maps and find out how high that location was. That's interoperability between fields. Another example is when I was at an RDA conference, a Research Data Alliance conference, and sitting in a group about wheat data interoperability, there was somebody knocking on the door and saying, I'm going to tell you a story about Earth observation. We have satellites. We study climate. And the climate is changing. In Australia, after the last few years, we had summers soaring heat. So if we want to be able to feed the world in 2050, we need to couple the climate information to the phenotypic information and genotypic information of wheat. There are no walls of a silo if we really want to be truly interoperable. So terminologies, not only in our own field, but also in the neighboring fields, are very important. And then, of course, sufficient metadata to actually do the interoperability. And there I can refer back to the images of the Russian and Japanese clouds. You really have to make sure that you have sufficient data describing how you obtained it to make the interoperability possible. So that completes, I think, the I, and then we only have the R left. So There, we need to document the provenance. So how did we obtain this data? Very important. This is a very essential part of the metadata. And for yourself also very important, because this is, again, one of the things on the bingo card is, yeah, but people will come and ask. If I publish my data, people will come and ask me questions, and that will take me time, and I don't have that time. Yeah, but if you properly document the provenance, it will prevent people from needing your time to actually be able to use it. The data will speak for itself. So, important also for provenance, and that's if you think about it early again, if your data comes from a machine, probably that machine can store its settings automatically. But if you think about that 6 months down the road, probably the settings have changed. So that doesn't work. Doing that automatically is really a big help. This is a really dangerous statement, and in earlier cases where I've said it, people misinterpreted it. So I'll be very explicit about what I mean. So I italicized minimal metadata. So it says use minimal metadata standards, but those are standards that are specifying what the absolute minimum set of metadata is that you need to be able to reuse data. Those minimal metadata standards are stored in FAIR sharing as well. So, for instance, in the biobanking community, there is the standard MIABIS. That is a minimal metadata about a biobanking experiment. And this is a reusable standard. You can really look what kind of metadata I should store to make my biobanking experiment reusable. And there are hundreds of those. So again, another example, MIAPI, the minimal metadata about a plant phenotyping experiment. They're really making such a standard is hard work, and it's something that is done by scientific communities as a whole, and it takes a long time to do. So if it exists, I really advise you to use it. So the danger in it is that I got questions afterwards saying, why do you say that you have to store minimal metadata? Isn't it better to store more? Yes, of course. And there are optional fields in these minimal metadata standards, and I encourage you to fill them. But the minimal metadata standard is the absolutely essential part. So choosing a liberal license is another one. So there are many different licenses that are applied to data, and two that are generally considered acceptable are the Creative Commons BY, the CC BY license, and the CC0 license. My personal preference is to use as few restrictions as possible. So I am even try to say, don't use CC BY. Don't require people to cite you if they use your data. An example why that would be the case, imagine that Gauss, who knows what Gauss did? Gauss made the normal distribution. Has anyone ever used the normal distribution? Yeah, everyone. And has anyone ever cited Gauss? I have not. Congratulations. I tried to read it, but it's in Latin, and my Latin is too rusty. So, obviously, we all find it acceptable that we do not cite Gauss anymore, and I really find it acceptable. But if there would be a legal obligation, we would all have to cite him, and we would have probably citation lists that are not, after the average paper 20, but 100,000 papers, where we are standing on the shoulders of giants. At some point, we just have to say it's unreasonable. But if there is a legal obligation, we have to. So I encourage people to leave off and to just trust the honor system that we have also for papers. And Ewan Burney actually had a good insight and a good way to formulate this. He said the other scientists will cite it anyway, because they will need to prove that they got the data from a reliable source. I think that's a really good one. So the last thing I have on this slide is we have to make sure that the results are not only narrated. And I think also in the questions in the morning session I told about this already. We tend to reserve the most important conclusions for our papers, and those are not computer accessible. And we heard from Eric about text mining 20 million abstracts. We don't want to say that in 10 years we are text mining 30 million abstracts. because it's much better if we stop hiding computer-readable information in human-readable text. So, summarizing this part is use the experts that are there and also be expert, because we are each other's help as researchers. Everybody is an expert in his own field and needs the expertise of the others. And in the process of the European Open Science Cloud, actually, there is a currency that is called cloud coins that I hope will make this a bit more sustainable, because that is, of course, a very difficult problem at the moment. So, those were the 4 letters, and then I promised to come back to the data stewardship wizard. So, for the specifics about the project, we are working on this tool, and we set out to say we want to make a tool that is encompassing as much information as possible about the good data management that we can find from all the experts. And I've been interviewing experts, I've been going to conferences, and I collected an enormous mind map full of this information. And then I encountered these people from the Elixir node in the Czech Republic, and they said, we know how to put this into a web tool, to turn this into a web tool. So my hierarchical mind map of all kinds of aspects of data management is now turned into a tool that, just like other tools for making data management plans, and this cannot actually write the data management plan, it can only guide you through some choices, but just like them, it goes through a number of questions. But many of these questions are actually yes or no, or very simple choice questions. And if you look at the triangles behind these, the yes and the no, if you click on any of those answers, followed by such a triangle, it folds out relevant questions that are only relevant if you select that answer. So there may be hundreds and hundreds of questions in this thing, but you only get the ones that are relevant to your project when you guide it. And this way, you can really enrich the data management plan, because it will help you think about things that you have never thought about yourself. There are also features in there, like if you do use 5 different databases, or you produce 5 different output files, that you can describe or answer these questions for each of the 5. At each stage, we're trying to put little bulbs in there with primary guidance, external links, the names of experts in the world, and also, if you run your own, if your institute runs its own copy of this system, they can put their own experts and their own references and own telephone numbers in there. So those are possibilities. And finally, we're also referring to a book written by Professor Barend Mons on data stewardship for discovery. And many of the questions are synchronized between his book and the wizard. So, I'm coming back to this slide. We actually have a way to make this second circle of growing data stewardship knowledge that benefits the data management process. By raising the awareness where the efficiency can be gained and where we can learn from each other, from each other's mistakes. The wizard really helps the researchers to discover what they have never thought about, but it also functions as if you have a data steward in your group. If you have a data steward, they can use this as a checklist. And they need a checklist. It's similar to a pilot. A pilot is the only person in the world that can fly a plane, but they use a checklist to do it safely. And in my opinion, a data steward uses a checklist to fly the data plane safely. So my call to action for you is use other people's expertise. Everybody that is now an expert became wise through their own mistakes, and we don't have to fall into the same traps, all of us.
Excellent. Questions? Comments? Overwhelmed?
I have one. In terms of, we're talking about data stewardship, which is also the long-term preservation. So one question that was raised as well at the EUSC meeting in June was like, who is going to pay for after the project is finished? So it seems that during the project, probably the funder will usually pay or should pay for the whatever percentage will be, which is the data production and so on, the data related costs. But after the project is funded, if you're talking about 10 years storage, who should pay? I don't know, in the Netherlands, did you come up with any solution?
This is not a really solved problem. This is really a discussion that is going on worldwide. So many of the data resources are curated data resources. They're the very valuable ones. Uniprot is curated. They have, I think, a team of 200 people that is continuously working on improving that data set and augmenting it. And this has always been paid by the Swiss government. Is that sustainable? I don't know. We would not be able to live and do biological research without Uniprot. So it is really essential to think about it. But they came out, I think last week, could be 2 weeks ago, also with a paper in F1000 Research, where they showed that the total cost for all of biology to maintain all these databases for eternity is less than 1% of the budget of life science research. So if it's less than 1%, I think we should be able to afford it as a community to maintain these valuable data resources. Now, of course, this generalizes it. There's one other aspect that I find very interesting to think about. So let's assume that Switzerland says, we don't do this for the world anymore. We have enough. We are no longer paying for the whole world of using Uniprot. So it will from now on stop at the border and we will only do it for Switzerland. Probably they can get rid of 5 out of the 200 people. They will still need 195 people to maintain the resource. And this is what Nicholas Blomberg, director of Elixir, calls a non-depletable resource. So no matter how many users you have, your investment is very comparable. So whether they do it for Switzerland or for the world, it doesn't make a difference. If they want to do it for Switzerland, they can just be very generous and do it for the world as well. And if every country has a resource like that and maintains that, we can actually get it funded as well. We don't have to actually make a big European or worldwide pot and then share it again. Because for these non-depletable resources, we can all say we are generous and we maintain our own, but we make it available to the world. This is, of course, much more difficult for resources that are depletable. For instance, trainings. So those need to be paid, but that's hopefully not an indefinite expense. Computing, expertise, those are depletable resources and they need to be made scalable. But for the things that by nature are scalable, I think generosity and sharing the responsibility over the world will actually work.
Also, every year this gets cheaper and cheaper. If you look at the last 40 years, of course, the price of storage, the price of storage has gone down tremendously. So every year that burden in terms of the storage cost will be at least less and less for these institutions. Yeah, so that's the storage costs, I agree, but I didn't mention the storage cost of Uniprot, but it's the cost of maintaining 200 people, experts that are curating the database. Oh, yeah. that is not going down. No, that is still there, of course. Yeah.
But the same Moore's law that's driving down the cost of storage is amplifying the amount of data production too. And I don't know which one wins in the end. So there are some nice. So since we were in the horror story and horror stories anyway, I once attended a nice talk by 2 people in the Netherlands from the Netherlands Proteomics Center presenting repositories for proteomics data. And this was probably 8 years ago. And when they started their presentation, they said, well, life has become easier for us.
because we wanted to present you 7 repositories, but the 2 biggest ones have just gone out of business. And this is a general issue. So a lot of fields have repositories that are started as a project, and they are successful, and they have the good data model, they support the right kind of questions, and everybody starts submitting their data, and that's for free. And then they grow until they go bust. And one of these 2 was just going like that. They just went offline from one moment to the other. And the other one said, download your own data, you have 3 months.
But as I understand too, UniProt is reapplying for funding like every 4 years.
Yeah.
So it's everyone's sweating and writing proposals every 4 years, hoping.
Yeah.
It's not the end.
So there are, again, so I'm full of stories. In 1995, the Protein Data Bank went through such an episode. And they had funding every X years from the Department of Energy. And at some point, the Department of Energy said, but we doubt now that you're running this in the right way. And they said, we are going to open it up for other applicants. And that was when the PDB worldwide was born, with PDB in EBI, PDB in Japan, and the PDB at Rutgers. And they are running a much more reliable, much more automated, semi-collaborative and semi-competitive mode that is really, I think, brilliant for science. And the moral of this story is, of course, that if you just have a resource that gets infinite funding, then they don't have to innovate anymore. So you need to keep the pressure on innovation. And I think the PDB is a very good example of how that has worked out very well.
This is kind of a related question, but a lot of the repositories that have come into existence have kind of shut down. So in terms of the FAIR principles, and as an individual researcher, is there any guidelines on which ones which repositories you should try and pick, or is there anything to look for in terms of picking the right repository that's going to maintain the data for a long time, or is that just kind of chance as to whether that repository is going to last or not?
So I am hoping that the repositories that are certified are on average going to be alive much longer than the other ones. So there is the World Data System. That's one one certification. There is the Data Seal of Approval that comes originally out of the Netherlands. They have been working together to make yet another standard with an abbreviation that I can't even remember. And then I said the ISO standard for repositories is also very, very strict. You have to look at repositories that are being run by repository experts as a service that is it's provided by experts. Repositories often start, and those are the repositories that sometimes go out of business, by people that are themselves users of the data. And in the early years of such a repository, that is a serious danger that they will go out of business when the funding stops. Elixir tries to make a list of depository resources, so repositories where you can actually store your data safely, and that is a subset of the Elixir core resources. And the Elixir core resources have been evaluated for their fairness and also for their impact on biological sciences. And so those are repositories, I think, that you should blindly trust.
Maybe I'll just follow up real briefly on, I mentioned that we have the FAIR metrics. This paper came out just on Friday. And the way, so for example, in F1, there's a requirement to have a persistent identifier. And so how can you guarantee the persistence of your identifier or your registry? The way we handle it in the FAIR metrics is just to say, do you have a link to a document that states the policy that you have for persistence of that resource, be it a registry or a data repository. So is there a link to a document that says, we plan to be around for this long, if there's an emergency and we have to go online, we'll give you 6 months notice. That's a policy for your persistence, and the FAIR metrics are just looking for that policy. So a data steward can then be informed in a smart way about which data repository to go to or registry.
Thanks very much for the presentation. It's been a great day, and as a statistician, I'm familiar with a lot of the stuff that goes on behind the scenes. I think at a policy national level, perhaps it's something that we follow up again, maybe with the TMRN and with the CRFs and clinical research centres as well here, and have a direct connection maybe and follow up in terms of policy. But the question I was going to ask is about one of the challenges we see in terms of, say, Cochrane reviews and retraction of scientific papers. And Keith Bagley, I know, was a guy who, as a statistician, identified the importance of reproducible research, where he couldn't replicate a piece of work and realized that the header of the file was misinterpreted as data. And so the whole analysis was wrong and papers were retracted afterwards. But how do we ensure that the registries and databases flag data that's been retracted or studies where there's been errors? Is there a process by which we can do that?
So what we recognize is that there are two different kinds of metadata for data sets. One is the metadata that come with the data, that the depositor actually adds to the data to make it readable. There is also metadata that comes after, and it's interpretation that is from people that actually try to reuse it. That is citation data, people that have reused it. And I've heard the term reverse provenance mentioned. So you know that a data set is very reusable if it has already been reused several times. Of course, that has a slight delay, but it is a definite measure. But the semantic web technologies that we are actually working on ourselves to make FAIR tools, it has the possibility of referring to any data set and describing an experience or a property of that data set, such as a bad experience. So yes, that is possible, and we actually have a tool called the Open Research Knowledge Annotator that is capable of doing this.
Orca.
Orca.
So, which is really cool because an ordinary person can kind of make their annotation and publish that as a FAIR data element. So your commentary itself or your annotation is also FAIR data. And I would say too, a retraction is a publication. Yeah. And even if a paper is retracted, it's not that all record of it disappears. The paper still is there and the metadata for that paper is still there, but now there's metadata built on top of it saying, oh, this was an error and should no longer be believed.
Hi, just to add a bit about what we're doing about the research repositories. I know I'm a member of the Science Europe Task Force, which is looking at lists of recommended repositories and the criteria that should be within a repository that is recommended that people should use for certain communities. So we've looked at about 58, I think it is now, of recommended repositories across 4 different seals of approvals to see whether they're approved in different data registries or not. And there will be a recommended set of criteria that repositories should adhere to, like persistent identifiers and other things that will be discussed at a meeting in Brussels on the 30th of January with the Commission and some of the editors of journals and some of the leading players across Europe. And the intention is that there would be a common approach to the use of research repositories, and a proposal probably that, and this has to be written yet, but that there will be a flag put on some of the criteria that will adhere to those recommended criteria, and that eventually that there would be a certification process that you have to be certified to maintain those recommended criteria to be used. But to give you a very practical example, of which Holly Dawn will talk about after the break, the HRB Open Research publication platform has a list of recommended repositories that we have been through, and Teresa has looked at these as well and gone through them, and there is a repository evaluation form on the system which outlines all of the criteria that the HRB think at the moment are relevant for a criteria as a repository should have to put your HRB funded data. Just on the how this is actually measured, I mean, one of the things that I think is that the research integrity agenda is somewhere where we look at the actual implementation of good practice, and the research data and the research integrity forum should really work closely together in the institutions on this. And just on the cost benefit, one of the things that Annalisa mentioned was about the cost and who bears it. I mean, at the moment, the HRB intention isn't to look at paying for long-term curation and preservation, and funders typically don't do this. This falls beyond the funding of research. So the reuse of that data would be something possibly that we could look at, but the actual curation you will find across any of the European funders, they do not fund that element of it. But there are a number of cost-benefit studies that have been done at a national level which show how much it costs, and these are usually 40 years. So I think Belgium, Sweden, and I think it's Norway have done one at the moment, and they've looked at a 40-year plan, and the first 20 years there is a national cost that is reaped or gained back, I suppose, in the last 20 years of the study, but for the first 20 years there will be a cost. So I think that we do need a national conversation on who's actually going to pay for the long-term preservation and courage of data.